What is an adiabatic process? A process in which pressure changes, the volume changes, the temperature changes, but there is no heat exchange with the surroundings. Means a process, you will draw PV diagram. You have a non-conducting. Walls are non-conducting. Cylinder walls, piston, all are non-conducting. This is connected with the wheel. All are non-conducting. You have a gas inside. At this point, it is point 1, pressure is P1, volume is V1, temperature is T1. The piston shifts during expansion, shifts to a new position 2. Expansion takes place, piston moves from position 1 to position 2. Such that pressure during the process changes, volume changes, temperature also changes. But there is no heat transfer. So adiabatic process is a process in which thermodynamic process in which pressure, volume, temperature change, but no heat exchange with the surroundings. For such a process, the relationship between P and V is P V's power gamma is equal to constant. Gamma will be given by the examiner. Say gamma is equal to 1.4. Say for approximation you can take it 1.4, 1.5, 1.6. Examiner will give you this value. So first part, what is adiabatic process? A change in pressure and volume of a gas in which temperature also changes is called adiabatic process. In such a change, no heat is allowed to enter or escape from the gas for adiabatic process. Relationship between P and V is PV's power gamma is equal to constant. Second part, essential conditions for this process. Essential conditions. Condition number 1. Yes. Processes. First is no heat exchange. We can change the sequence. First is no heat exchange. Heat won't enter into or come out. So no heat exchange with the surroundings. Two, process is fast. Process is fast. Sudden. So fast that there is no time to exchange heat with the surroundings. Time with is 4 minutes. 4 minutes to write A and B part. Once again, what is the adiabatic process? Process, thermodynamic process in which pressure, volume and temperature change, but there is no heat exchange with the surrounding. The relationship between P and V is PV's power gamma is equal to constant, gamma is equal to 1.4 or examiner may give you 1.5 or 1.6. It is say 1.4. Essential conditions. In isothermal, condition was slow. and there was heat exchange with the surrounding. In this process, adiabatic process, no heat exchange with the surrounding. Process is fast, sudden. C part. नोट्स बंद कर दो. C part. First part is relationship between P and V for adiabatic process. P V's power gamma is equal to constant. Means what? P1 V1's power gamma. That is this point. P1 V1's power gamma is equal to P2 V2's power gamma. Competition questions. They will give you pressure ratio, P1 to P2 ratio. You have to find out V1 to V2 ratio. You can find out. This is one. Second is, yes, V and T relationship. V and T relation. See, P V's power gamma is equal to constant. That is one. P into V is equal to nRT is always true. Whatever be the process, this equation is ideal gas equation is true for all processes. From these two, we want to find out relationship between V and T. V and T. There are how many parameters? Gamma is a constant. This is also constant. P, V, T. N and R are constant. There are three parameters. P, V, T. You want relationship between V and T. How to proceed? You have to eliminate P. So divide 1. If you call this equation 1, this is equation 2. Divide 1 by 2. 2 minutes, solve it. 3 minutes total. Write this point, then try this one. Divide 1 by 2. When you divide 1 by 2, P is cancelled, that is PV's power gamma divided by PV is equal to constant. N and R is also constant. This is constant into T. P is cancelled. What you get is V's power gamma minus 1. T in the numerator, T's power 1 is equal to, this is a constant, this is also constant. So what you get is V's power gamma minus 1, T's power 1 is constant. That means from 1 to 2, what you get is V1's power gamma minus 1, T1's power 1 is equal to V2's power gamma minus 1 into T2's power 1. This is what you get between any 2 points on adiabatic process. That means if a volume ratio is given to you, you can find out a temperature ratio, or if a temperature ratio is given, you can find out a volume ratio. So you have PV relationship, you have a VT relationship. Third one more, yes, PT relationship. PT relationship. VT relationship I can write here. V's power gamma minus 1, T's power 1 is constant. Third, PT relationship. Again, you have 2 equations. How many parameters are there? P, V, T. You want to get relationship between P and T. You have to eliminate what? V. So you have 2 equations. Eliminate V. Easy. Equation number 2, take value of V from equation number 2 and put this value in equation number 1. 2 minutes with you. If you take value of V from second equation, V into V's power gamma is equal to constant. Equation number 1. Equation number 2, V is equal to what? nRT by P. nRT by P. You need not worry about N and R because it is constant. So P's power 1, T's power gamma, T's power gamma divided by P's power gamma is equal to constant. Means what? P's power 1 minus gamma into T's power gamma is equal to constant. So equation number 3 is P's power 1 minus gamma, T's power gamma is equal to constant. This is how P and T are connected. D part deals with what? D part deals with what? Examples? Yes. First is what? Bursting of a tire. It's a fast process. Cycle tire. You keep on increasing the pressure at certain limit, it will be more than the braking strength of the tube and a blast will take place. Bursting of the tire is a sudden process and there is no time to exchange heat with the surrounding. When I speak, sound travels so fast in air, that is sound in air or gas. It travels so fast that there is no time to exchange heat with the surroundings. It is also adiabatic process. 2 minutes to write. Numerical number 4. Numerical is a tire pumped to pressure of 6 atmosphere bursts suddenly. Calculate the temperature of escaping air given initial room temperature is 15 degrees C and gamma for air is 1.4. Write what is given, what is required. It is a discussion about pressure and temperature only. What is initial pressure P1 given? Initial pressure P1 is 6 atmosphere. 1 atmospheric pressure is 1.01 into 10 per 5, but we need not write because we may work with the ratios. Temperature, initial temperature, how much? 15 degrees C. 15 degrees C means what? 15 plus 273. Yes, in Kelvin, 288 Kelvin. Fine. P2, when the tire burst takes place, it is at 1 atmosphere. Once the air is out, it is at 1 atmosphere. Find T2. Find T2. Adiabatic suddenly means process is adiabatic. If it is adiabatic process, relation between P and T, yes, P and T is P1's power 1 minus gamma, T1's power gamma is equal to P2's power 1 minus gamma, T2's power gamma. In the question it is given gamma is equal to 1.4. Let me take gamma equal to 1.5. Why? Because if it is 0.5 under root, you can find out. 10's power 0.4 without calculator, it is not possible to do it, isn't it? So we'll do it without calculator. Let gamma is equal to 1.5. P1 is how much? Yes, 6. I can write P1 by P2 spar 1 minus gamma is equal to T2 by T1 spar gamma. Put value. P1 is how much? 6 atmosphere. P2 is 1. 1 minus gamma. 1 minus 1.5 is equal to T2 I don't know. T1 288 par gamma. Gamma is 1.5. Find T2. What to get is 6 power 1 minus 1.5 minus 0.5 is equal to T2 power 1.5 divided by 288 power 1.5. Means what? It is T2's power 1.5 is equal to, this is 6 power minus 0.5. I can write it like this, 6 power 0.5. This is 288 power 1.5 means what? 288 into 288 power 0.5 means 288 under root. This 6 power 0.5 means what? 6 under root. Find T2. This is T2's power 3 by 2. This you can write, just a minute. You can write this as 288's power as it is, 3 by 2, 288's power 3 by 2 and 6's power 1 by 2 as it is. Now it is easy to solve it. Try. Find T2. Find T2. What you get is T2 is equal to 288 divided by, yes, cube root of 6, isn't it? Taking 2 by 3 power on both sides, 2 by 3 of this, 2 by 3 of this, 2 by 3 of this. When you take 2 by 3 of this, that means what? 6 power 1 by 3. It is equal to what? 6 cube root of 6. It lies between, yes, 1 and 2. 1's power 3 is 1, 2's power 3 is 8. So 1.5 power 3, just check how much it is. 1.5's power 3 is how much? 1.5's power 3 is how much? 1.6 power 3, 1.7 power 3, just try. 1.6 power 3, 1.6 power 3 is how much? 1.6 power 3 is equal to what? 5, 5 point something, 1.7 power 3. Try 1.7 power 3 and 1.8 power 3. 1.7 power 3, 1.8 power 3. Yes. 1.8 power 3 comes out to be? Approximately we can take it like 1.8. If I take it 1.8, 288 by 1.8 is approximately equal to what? In Kelvin, 288 by 1.8 in Kelvin. Approximately 160. It is approximately 160 Kelvin. See why the answer is different from the book? Because we are taking gamma to be 1.5. In the question, gamma is 1.4. One more numerical number. 6. B part. Numerical number 6. A quantity of air at normal temperature is compressed. A part is slowly, that is isothermal process. B part suddenly to 1/3 of its volume. Find the rise, underline rise in a temperature, if any, in each case. Gamma is 1.4. Repeat. A quantity of air at normal temperature is compressed. Leave A part. Slowly means what process? Isothermal. In isothermal process, temperature remains constant. So there is no rise in temperature. So A part is not required. B part suddenly to 1/3 of its volume. Initial temperature is what? T1. Normal temperature means what? Yes, 273 Kelvin. Volume V1 say V0. Temperature 2 we want to find out. Then we will find difference of the temperature. Actually it is not T2, it is T1 minus T2 required. V2. Final volume is what? Yes. Initial volume is V0. You compress it to 1/3 of its volume. 1/3 of its volume. V0 by 3. Step 1. Find T2. A relationship between V and T. Yes. For adiabatic process, relationship between V and T is V is power gamma minus 1 and T is power 1 is equal to constant. Means what? V1's power gamma minus 1, T1's power 1 is equal to V2's power gamma minus 1 into T2's power 1. V1 is how much? V0. T1 273. V2 V0 by 3 power gamma minus 1 T2. what you get is T2 is equal to what? T2 is equal to 3's power gamma minus 1 into 273. Am I right? Because V naught power gamma minus 1, V naught power gamma minus 1 is cancelled. What you left with the 3's power gamma minus 1? 3's power gamma minus 1. Gamma is equal to what? 1.4. Gamma is 1.4. 1.4 minus 1. It is given gamma is equal to 1.4. 3's power 0.4 into 273. This value we don't know. 3 is power 0.4. 3 is power 0.5 means under root 3 is how much? 1.773. 3 is power 0.4. Can we take it 1.6? Approximate analysis. We don't have any other option without calculator. That is the only way to do it. 3 is power 0.5 is 1.7. 3 is power 0.4. Let me take it as 1.6. If I take it 1.6 into 273, comes out to be what? Solve it. Yes. How much? 436.8. Say 436 Kelvin. T2 is 436 Kelvin. But question is, what is rise in temperature? Rise in temperature. Rise means what? Delta T. Change. Final minus initial. Final is how much? 436. Initial was how much? 273. Approximately equal to what? Yes? 163 Kelvin. Yes? This is fine. 163. Answer here is 150.6. Say 151. Why there is a difference? Change? Because we are moving with approximation, not by exact method. In competition, you will get gamma is equal to 1.5 because under root you can find out accuracy level will be high.